It's where we're doing f of g of x and g of f of x. Also inappropriately called fog and golf. You guys don't call it that? Thank goodness. Most of the time when people see this f of g, they call that, oh yeah, fog and golf. It's not what it is. It's a composition function, and we read it as f of g of x and g of f of x. So here are the notes. Composite functions are made up of two or more functions where the output of the inside function becomes the input of the outside function. Yeah, makes sense. H of x being f of g of x being f depends on the output of g, and g depends on the input of x. The domain of f of g of x is a subset of g's domain that will produce values in the domain of f. In other words, order matters. So to me, this one, knowing what a composition function is important. This one's important. I'll explain it in a second. And like I said, that means like you can't inverse the operations and get the same thing. So normally we say 2 plus 3 equals 3 plus 2, but that's not the case with a composition. If you build it in one direction, it's not the same as building it in the other direction. As you guys are copying this, I want to go ahead and make sure I say this at the beginning because I'll forget if I don't. You can do a Canvas assignment after today's lesson. 2.3. We're going to start with a table of values. So normally when people teach compositions, I have found that people do tables last, and then they forget how to do it with a table. If all you are given is a table of values, the composition of functions is super, super easy. Okay? But people overthink it. So let's look at this. If I want to read this out loud, I would say I'm finding f of g of 3. F of g of 3. So we work from the inside out with compositions. So the first thing I want to find is, what is g of 3? Do you guys know how to find g of 3? So what am I plugging in for x? 3. So I'm going to go to where x is 3. What's the y value of g when x is 3? The y value is 5, right? That's an ordered pair. So g of 3 evaluates to be 5. Do we follow that? Does it make sense? And so I can substitute. G of 3 is the same thing as 5. So now I'm just finding f of 5. So now I'd go to where the x value is 5. The y value is 7. So f of 5 is 7. It should be 1. I went to g of 5, didn't I? My fault. See, I messed it up after I talked about how easy it is. If I go to x being 5, the y value is 1 for f. So the answer is 1. Can you guys do the rest of those? Try them. D's a little different.
What does that one mean?
Same thing. Just a different notation. Another way we can write, this is g of f of 3. We could write it as g of f of 3. Just different notations. We finished with B. We should start with f of 3. F of 3 is 7. And g of 7 is 8. So B should be 8. Questions there?
Wait. How's G of 7 8?
So I plugged in 7 for x. And so I'm plugging that into G. So when the input is 7 to G, the output is 8. Go with that? On C, f of 1. F of 1 gives 5. And so then I'm finding G of 5. G of 5 is 7. What about D's? Anybody think they figured that one out yet? That's correct. It's kind of working backwards here, right? I don't know what I'm plugging in to start with, but I know in the end I have to get 7. So here's what I could think of. If I plugged in something to F to get out 7, what did I have to plug into that? I had to plug into a 3. Do you follow that? So that means G of X needs to be 3. So what makes G of X be 3? 1. So the X value has to be 1 from the very beginning. Kind of follow how to do that backwards from a table. Cool. Okay, we'll go ahead and start on A. Start on the inside. So what is G of 3? Well, it tells me here the absolute value shaped function is my function G. So if I go to 3, I find the Y value to be 1. So G of 3 is 1. So now I'm finding F of 1. So F is the quadratic. So I go to 1. I go up to the Y value. When X is 1, it's at 4. So my answer here should be 4.
Wait, how do you know it's the absolute value?
Because of the shape. The only graph I have that's a V shape is absolute value. My 6 parent functions. Do you remember from... This is x squared. A line is x to the first. This is x cubed. This is the square root of x. I mean, that stuff doesn't matter to this. I just was trying to give you a quick review. That's a cube root of x. This is the absolute value of x. Is that the 6? Those are the ones we learned, I think. So by the shape of the graph, we should be able to identify the parent function. But again, that's not the point of this problem. It's just a review of stuff we've already done. Trying to bring it back to our minds. All V-shaped graphs are absolute value graphs. You have a question about the question?
Excuse me, teachers, if you haven't posted attendance, please go ahead and do that.
Have we already done B? 0. Do I need to go over that one? C. Don't need to go over that one. D. Don't need to go over that one. I can go over any of them I need to, guys. Don't sit there if you don't understand it. Like Coach Mitchell said, we're all family, right? We're okay. Admit when we don't know something. Into, oh, I didn't mean. So we've got three functions, f of g of h of x. And that all equals big F of x. See the difference in lowercase and uppercase? Those matter here. So if the big F of x is 1 over x squared plus 5, how could I build that? So, like, again, I don't know a good way to teach this. To me, when I look at that whole big scale, what's the first parent function you see? Like, what's the first one you notice? Not to me. To me, I see 1 over x. Is its big overarching theme. Like, that's the last thing that's happening here, is a 1 over x. And then inside that 1 over x, this, like, I can see this used to be an x, but I somehow plugged in an x squared plus 5 there. Do we see what I'm talking about? So that means somewhere farther inside, I got it to be x squared plus 5. So I'm starting on the outside with 1 over x. So I know it's a or d from the get-go. Well, if those are my only choices, look at the next part. It's either x plus 5 or x minus 5. Well, which one of those do you see? Hopefully you see plus 5. But there's not a minus in that problem. So what you can think of, we started with an x squared. And we plugged x squared back. Started with an x squared. We plugged x squared into g of x. So where it used to be x plus 5, it became x squared plus 5. And then we plugged x squared plus 5 into 1 over x. So it became 1 over x squared plus 5. I think this is a bad one to do at this point. I think this should have been the last problem they gave us. Okay? So let's come back and revisit this after we've done a few of the other ones. That's probably what I should have done to start with. Oh, they don't do any that are any easier. Great, wonderful. Okay, so obviously let's look at this. If I had f of x was equal to the square root of x and g of x was equal to x minus 1. What if I wanted to find f of g of x? Okay, I'm making this up. Have you guys done stuff like this?
Yeah, we can just plug in the g of x to the x of the f of x.
Yes. So another way to say g of x is we know g of x is just x minus 1. So we're really just finding f of x minus 1. Do we follow that? Because g of x is x minus 1. They're the same thing. So now I'm going to plug x minus 1 into f. So where there used to just be an x, now I'm going to put x minus 1. So f of g of x is equal to the square root of x minus 1. We good with that? Now what if I go the other direction? What is g of f of x? Yes. This time I'm plugging in f of x, which is radical x. And so everywhere there used to just be an x, now I'm going to plug in the square root of x. So g of f of x would equal the square root of x minus 1. Act like it was just plugging in any other number. Do we need to do a few more like this? Or do we think we've got this down? I can't believe it just completely skipped that. It went straight from doing it with tables to building a triple composition to now we're talking about the domain. I can do as many of these as I need to. I can make them up if we need more. Nobody? Not only are we finding f of g and g of f, but we're also need to state the domain of the function. Okay, so let's start by just finding f of g of x. So what's another way to say g of x? We could just say the square root of x minus 9. So I'm going to go to my function f. Everywhere there used to be an x, I'm now saying radical x minus 9. So I'm going to plug radical x minus 9 in to x. Like that. So this is the composition. Is everyone good there? Now, the second part. Here's the trickier part. When I have to state the domain, here's how we do that. We start with the inside function, because if I can't plug x into the inside function, then it's not valid for my domain anyways. So my inside function here is g. So what is the domain of g? So we talked about domain very briefly. I talked about the domain by default is what? Like, if there are no problems, what's the domain of a function? Yes. By default, the domain is always all real numbers. Unless you have one of two things happening. There are two things we are not allowed to do in math. Take the square root of a negative or divide by 0. If one of those things happen, then we have to adjust the domain. So here in g of x, which is the square root of x minus 9, there is no divide by 0 possibility, but there is a square root of a negative possibility. So how can I be sure I do not take the square root of a negative? Yes, so here's what we do. Take what's underneath the radical. We said we can't take the square root of a negative. So what's underneath the radical cannot be negative. That's how we say that. X minus 9 must be greater than or equal to 0. In other words, can't be negative. Are we following? People seem to never understand this, so I can solve it to find that the x must be greater than or equal to 9. So g, the inside function, tells me this is the domain. It's already been restricted. So it's no longer all real numbers. It's only all real numbers greater than or equal to 9. Then, once we found the domain of our inside function, we must find the domain of our big composition, which is here. So what possibilities could happen in the final big composition? Is there a possibility I could divide by 0? There is. So I need to fix that first. So how can I make sure I don't divide by 0? Well, so here's how we do that. If I want to make sure I don't divide by 0, then this can't be 0. Right? So I could just set that up. I could say the square root of x minus 9 cannot be 0. And then solve it to find what x could be. So how could I solve this? Well, first there's a square root of both sides, so I would need to square both sides. When I square a square root, those cancel, and I'm left with x minus 9. 0 squared is 0. And then add 9. So x cannot be 9. Okay, is there a possibility of taking the square root of a negative in the big function? There is 2. There's that possibility. So what would I need to do? I would need to take what's underneath the radical, say that it must be greater than or equal to 0. For us, we've already done that this time. Right? It's the same thing. So I have to combine these two restrictions. The first one says x must be bigger than or equal to 9, but this one says it can't be 9. So how can I combine those two things? X is greater than 9. So my domain in total is x is greater than 9. We could write that as 9 to infinity, both with parentheses, right, if I'm going to use interval notation. Okay, first let's build g of f. Could you do that? So build it. There's my composition. Do we get that done? Hopefully that doesn't take too long. Now, find the domain. So what was the process we had to go through to find the domain? Start with the inside function, which this time is f. What are the domain restrictions that f gives me? I can't divide by 0. So that means the denominator cannot be 0. So now the domain is everything but 0. Everybody's good with that? Now the second thing, we look at our built composition, which is this big ugly thing. What domain restrictions could happen there? Could we divide by 0? We could, so I need to account for that. I would just say the fraction can't be 0. I get the same thing here, right? This big ugly thing, could I take the square root of a negative? Yes. So I need to make sure I don't take the square root of a negative. So remind me, how do I set that up? How can I make sure I'm not taking the square root of a negative?
You know, just say square root of over x minus 9 to be not equal to 0.
No.
Greater than
This is why when I asked you on the last one, I said, do we understand that? Are we following? Because people mess this up all the time. How can I make sure I don't take the square root of a negative? What's underneath the radical? I don't care about the radical anymore. I just care about what's underneath the radical. Can't be negative. So what's underneath the radical can't be negative. You guys, can you guys understand that in this statement? This is what's underneath the radical. This means can't be negative, greater than or equal to 0. You see how it ties together? So that's the second time we've done it. So when I try the next time, we'll see if it sticks that time. I don't know. It's not just you. I'm frustrated with myself because every year I teach this, we never can do it. And I don't know what I'm missing. I don't know what. I need to do a better job. And I don't know how to do a better job. And that frustrates me. Anyways. If I need to solve this, what do I need to do? Add 9. Uh-oh. 1 over x must be greater than or equal to 9. The easiest way to solve this is graph it. So I'm going graphing calculator. Yeah, the third drawer for you guys. Is everyone here graphing calculator? So, do you guys remember when we had a quadratic? This was a canvas problem only, where the quadratic had to be greater than 0. And so I made us graph it and see where is it above the x-axis. So here, we're saying this rational function must be above or equal to 9. So what I want to graph is two things. I want to graph the rational function, which is 1 over x. And I want to graph y equals 9. And I'm going zoom standard.
Is this going to be posted?
Yeah.
Alright.
You going to volleyball? It'll be up. I'll put it up as soon as this class is over.
Thank you.
Uh-huh. So when I graph this, here's what I've got. Right? This shouldn't surprise anybody. 1 over x is a rational function, has a vertical asymptote. You got all those things going on here. And then y equals 9 is this line. So I'm looking for where is this greater than this line? Well, over here, does this ever go above the line? No. Here, would this go above the line? It doesn't show it. But what is this? A vertical asymptote. It's a rational function. Where's this going? To infinity. So at some point here, it's going to go above that line. So I can find where by using intersect. Right? So I can go second calc, intersect. I want to know where does the blue line intersect the red line. It makes me give a guess. I got 0.11111. 9. What's another way to say 0.11111? 1/9. Yeah. It's 1/9. So if they intersect each other at 1/9, and I'm looking for where's the graph above 9. So where's it above 9? Well, from 0 to this point. Do we follow it? Because at 0, it can't be 0, because 0 is a vertical asymptote. So from just past 0 all the way to 1/9. And because it needs to be greater than or equal to 9, it's a bracket. Include 1/9. Do we have any problems building the composition? Or can I do that fairly easily? So if I'm finding g of f of x, I'm plugging in f. We good with this? So now, this is 3 times 1 over x squared minus 5 times 1 over x. Well, we can multiply those. So this is 3 over x squared minus 5 over x. There's my composition. What a mess. Any questions on finding that composition? It's a little uglier than the ones we've been doing, but it's the same process. Now, domain. What's the domain of the inside? The domain of F. That's it. We could have a divide by 0 error, so we set the denominator and say it can't be equal to 0. G, we don't have a square root of a negative problem, right, because there's no radical. But could we divide by 0 again here? We could. So make sure the denominators can't be 0. So I could say x squared can't be 0 and x can't be 0. So how would I solve these? Square root. So this would be plus or minus 0, which is still just 0. And this one's still just 0. So the domain, all of them say the same thing. You can't pick 0. So how could I say the domain is everything except 0 in interval notation? Negative infinity to 0, union 0 to infinity.